So as part of the next discussion, we would be working on this dataset called cars.csv, and we are going to predict miles per gallon using all of these inputs. Alongside, when we discuss this, we will also bear in mind all the model assumptions. So let us deal with this dataset called cars.csv and let us try to predict the miles per gallon. I'm using the function called read.csv, and within the brackets I'm giving the location on where I've placed the dataset cars.csv. And I'm using tilde because this is MacBook. If you're using Windows, it will be C:/and the path where you have provided your dataset or whatever drive you have placed. Yeah, you need to provide the drive name also. I'm giving it tilde because it's MacBook. So read.csv, I'm using the assignment operator to assign this dataset to an object called cars. So let me run that. In this specific dataset, we have 81 observations, or we have 81 rows, right, or records, or this OBS is observations. In here we have 5 variables. It is also called as columns. And if you want to view this dataset, the function that you can probably write is view of the object name. And if you run this, you get to see that. Control Enter or Command Enter on MacBook is a shortcut to run any function. So now we have view of cars. We know for a fact that we need to predict miles per gallon based on all of these in, and this output variable y is continuous. Y is continuous, and you have multiple inputs. Output variable is continuous and you have multiple inputs, right? And if you have y which is continuous and if you have multiple inputs, you proceed with multiple linear regression. Okay, all right. Let me attach this cars. The moment I attach the cars, or if I do not attach the cars, let me show you. And if I want to refer to this column called miles per gallon, and if I want to calculate average of miles per gallon, or rather let me do a plot. Anyways, we need to do that, right? If I try to plot horsepower, miles per gallon, it has to give an error ideally. No, it hasn't. So it doesn't, probably because this is the only data set available, right? If you have another data set available, it would have thrown an error. Anyways, so here, if you want to refer to any of the variables within a data set, always it has to be cars $miles per gallon or cars $horsepower, so on and so on. But if you want to directly refer to these variables as miles per gallon, horsepower, rather than each time prefixing it with the name of the data set, then you need to write or run this function called attach. Now that you have attached, you can directly refer to these variables. Where did that go? Yeah, these variables. As I've told you, we need to spend 60 to 80% of the time doing exploratory data analysis. Measures of central tendency, dispersion, third moment, fourth moment. Third moment is skewness, fourth moment is kurtosis. You need to come up with the probability distributions. If something is non-normal, you try to transform it. You try to do graphical representation, so on and so forth. Assuming that all this is already done, we are proceeding further. So let me do summary. So summary, what does that do? Summary of cars will give you what is the minimum value, what is the first quartile, what is the third quartile, what is the maximum value, and what is mean and median for all the variables. And if you see that there is a huge difference between mean and median, that means there could be outliers. Even before you do your graphical representation, etc., probably you can do a summary and see. And if there is a huge difference, probably that warrants you to perform box plot. Yeah, because box plot will help you identify the outliers. And then what would you do with those outliers? You need to go and check with your subject matter expert. If box plot is going to display the outliers, go and check with your subject matter expert on, are those truly outliers or not? Or are those because of data entry error? Or is it a one-off scenario which doesn't occur in the future? If it's one-off scenario which doesn't occur in the future, you can delete that. Or if it is data entry error, go back and rectify or delete that from your analysis. That summary. Another thing is, when you build your prediction model, you always have to provide a note saying that the prediction model that we have built will work well only if the input variables are within the range. So if you come up with that equation, y is equal to beta naught plus beta 1 x1, so on and so forth, this equation will work well only if, suppose x1 is horsepower should be only within this range. If you have values which are less than or greater than, you cannot use this model for your prediction. All right. So this is how it works. Now let us proceed further with the analysis. Now we need to find out, the first step is scatter diagram, right? We need to find whether the relationship is linear or not, whether the input variables are better or not. So for that, let me do this. Let me remove that. We need to establish, or we need to check on what is the correlation between your output variable and input variable. We need to check what is the correlation between output variable and input variable. So output variable is miles per gallon, and whenever you write that function plot, it is always plot x comma y. So if you were to write, you'll write it in this way. Function plot of the input that you can probably choose is horsepower, and miles per gallon is the output. So it's horsepower comma miles per gallon. Look at this. You get the scatter diagram here. By looking at the scatter diagram, what are the various things that we might want to comment? The first thing is the direction of the correlation. It happens to be negative. Using your scatter diagram, you get to know about the direction, which is negative. That means as and how your horsepower increases, your miles per gallon decreases. What does your common sense say? Does your common sense also say that, yes, as and how the power of the vehicle increases, mileage decreases? Absolutely. Your common sense or domain knowledge or your subject matter expertise will say the same. So the data is good. The relationship is perfect. Second, we need to comment about the strength of the correlation. And you know for a fact that the strength when it comes to scatter diagram is subjective in nature. So I get a sense that it can be strong or it can also be moderate. So it's subjective. How do we objectively evaluate? Using correlation coefficient. We'll get to that in a moment from now. And the third thing is, more or less the data falls along the straight line, so you say that the relationship is linear. What do you do if the relationship is non-linear? You transform the data. What do you mean by transforming the data? You'll probably say, let me look at miles per gallon versus log of horsepower. Or you might want to do log of miles per gallon and horsepower, or you might want to take log on both sides. Maybe. Okay. That's your scatter diagram for this. In that way, since you have 4 input variables, you need to come up with 4 different plots. Up key would give you the previous function, up key on the keyboard. So I've done that. Let me do it for volume. There you go. You see that there is a negative correlation. I mean, it's tough. Your real world data sets are a little trickier for you to analyze, right? With exception to these, I sense that there is a negative correlation, which is very weak, and I see that it's linear. Rather than doing it for the rest of the input variables in this way, we have one function. Since there are 4, you might be tempted to do independently. But what if you have hundreds of inputs to predict your output? Then this logic will not hold good. All right, this logic would not hold good. Hence, we go with a function called pairs. Pairs of this cars data set. So look at what happens now. You get the complete data. You can zoom it even further. And quickly, we can look into the correlation between the output variable and all the input variables. And if you cut across this diagonal, the lower triangle here and the upper triangle would be more or less the same. It's not more or less, it's just a replica, right? So you can either look at this side or that side, doesn't really. It's kind of a mirror image. So look at this. There has to be a relationship between output variable and input variables. stronger the relationship, better will be your prediction. That means that input variable would be contributing very well for your output prediction. However, already discussed that if at all there is a relationship between different input variables, then it's called as collinearity problem. And look at this. What shall I say is the relationship between these two input variables, horsepower and SP? There seems to be a positive correlation. So these two inputs are related. And if the inputs are related, it is called as collinearity problem. There seems to be a collinearity problem. And even if you look at volume and weight, there seems to be a very, very strong positive correlation. So volume and weight are also getting involved in collinearity problem. So as part of scatter diagram, you came to know about that. So I would quickly do this. I would open a Word document and I would try to make a record of this, right? I'll record this observation. So as part of scatter diagram, you notice that there is collinearity between horsepower and top speed of the vehicle and volume and weight. Okay, seems like you have got a good insight. Now let us objectively evaluate this. How do you objectively evaluate the correlation? Using correlation coefficient matrix. Using correlation coefficient matrix, we objectively evaluate it. So let me run. This is a function in R, correlation of cars. Let me do that. Here is the correlation coefficient matrix. So you can look at the correlation between output variable Y and your horsepower, which is the first input. There is a negative correlation. You can look at the correlation between output variable and volume here. That's also negative, weak negative maybe, or moderate. There is a correlation between output variable miles per gallon and your top speed of the vehicle, and there is a correlation between the output variable and your weight. This and this seems to be okay. These two are slightly moderate, not weak though, but they are moderately correlated. Now you see that the correlation between horsepower and SP is 0.97. That means there is a strong positive correlation between the inputs. If there is so much of strong correlation, then why can't we use only one variable? Why do we need to use both the variables? These two are very strongly correlated. So rather than using two, you can use only one. And if you look at volume and weight here, the correlation is even stronger. It is roughly equal to 1. So there is very, very strong correlation going on between volume and weight. Why do we need to use both? Why can't I use only one rather than use two? That's another insight that you have drawn. So let me write that also. Correlation coefficient matrix has given very strong R value for correlation between horsepower and SP and volume and weight, further strengthening the inference that these are involved in collinearity problem. So we need to keep recording these kind of things at every step. We cannot just jump like that, build models without any prior knowledge.